All right, so alert silence notifications. We use Alert Manager to generate alerts, but also silence recurring alerts. So if there's a known issue, we'll put in a silence. And the issue that the on-call often faces is that the silence expires after some time that we put in. So, it might be 1 week or 2 weeks. And if the issue still exists, then they still get paged for it, or get paged for it again. And since the person who was on call 2 weeks ago has all the context around this, now this person gets paged and they reinvestigate the issue just for someone to come along and tell them, here's the known issue. And so we waste a lot of time. And so we've got it's basically a cron job that at the beginning of each shift posts to the production Slack channel the silences that are about to expire during the next 8 hours, during the next shift, so that the person coming on call has the context for all of the long-standing issues that might page them over the next 8 hours. And this went live, I think, just towards the end of last week. And we've already seen, let's make this a little bit smaller. There we go. So this is kind of what that looks like. And we've already gotten quite a few of these notifications, which I think also highlights how heavily we're relying on silences, something that we didn't have that much visibility into before. But I think, and I guess I just sort of search for the following silences. Yeah, so we can already see there's quite a few. And I guess, the response to some of these has also been quite positive. So yeah, that's basically it. It's a relatively simple change, but I'd say it's already having a positive impact.
Yeah, what I like about that is, like you mentioned, that the number of silences giving us a better idea of like what's going on there, but also like as that builds up visually, it will start to really dominate the channel, which will be a good sign for us to be like, hey, why is this list so long? Like, we'll get a sense for what we consider a reasonable length of that list, and hopefully that sense will shorten the list over time rather than just like get used to having a longer and longer list. But it could go either way.
For the purposes of the demo, could you also show where the alerts are, where the silences are stored?
Sure. We have a link here to the silence that is about to expire. And if I click that and share my other window, there we go. That's where that takes you. So alerts.gitlab.net is our alert manager web UI. And so this is that particular silence. You can see, yes, indeed, it did expire. We have also a reference to, so every time we create a silence, we add a reference that tells us what is the silence related to. So that also gives us the context. Oh, this silence is because of this production incident.
And helicopter posts in the issue to say,
Yes. So here's kind of the other side of that, where we cross-link this incident issue to the silence as well.
I'm curious, we don't have any validation between the incident or the issue that we're referencing being open and the silence, do we?
Not that I'm aware of, no.
Because maybe we should have, like, if we just kind of keep cross-referencing closed issues, that's sort of like, feels like an impedance mismatch between
could helicopter
the
just
two
reopen an
views.
issue, like when it comments, and just say, like, I'm reopening this because there's an active silence related to this issue. If you don't want this issue to be reopened,
it might come across as being exceptionally
a bit pushy.
passive aggressive, but yeah.
But yeah, I feel like, you know, that's a good point, that like a silence that's linking to a closed issue. I mean, maybe if it was like a silence for a week and then we closed the issue like after 6 days, maybe you don't bother to go and delete the silence at that point. But like, if helicopter's posting multiple times in a closed issue, that seems like an issue, a problem.
I think the piece of information that we're missing is, yes, we have a silence, but is this silence actively muting
anything?
Alerts, right? Because if we produce an alert, the silence catches it, and that is referencing a closed issue, then, well, a silence exists.
Yes, that's a good point. So we want to know when the silence actually took effect. Was the issue closed?
Can we make a change? And I think the answer is yes here, but it depends on how much work it's going to be. That tells you how many times an alert would have been triggered. I mean, we can look this up in Prometheus to some degree. How many times an alert would have been triggered since the start, and include that in the silence. So you could say inhibited or silenced 10 alarms, 10 alerts in the last day, it's silenced like 1 alert or whatever. And we can use, you can't use the alerts metric on its own, but you can use the alerts for state, which is really weird, but it works pretty well.
I mean, this data should really be part of the silence itself, right?
It's got the current, it's got the ideally, but it's got on the, it's at least an alert manager, it's got the current alerts that it's trapping, but I don't think it's got any historical value.
Historical
data. So, yeah. So but I mean, because what you might find, I mean, this is kind of Yagni, but you might find that people just start automatically refreshing silences at the beginning of their shift, not knowing whether or not they. So maybe if we added in there, like, this hasn't alerted, or also this is alerted 10 times, and we're silencing it onto a closed issue, like, that's also not good.
Yeah. Yeah,
I was also wondering. Oh, sorry, go on.
Yeah, I'm not sure how easy it would be to do that. Like the how often it would have alerted. I guess we could try and apply the alerting rule as a query.
If you take the labels and you look on alerts for state, counts over time +1. If you Google it, there's a way that you can look how many times that alert would have fired for those set of labels, and then that would be your count.
So if you go to the front page of Alert Manager, and the count that shows at the end there, is that just showing how many alerts we've had on that forever?
No, that's how many it's inhibiting at this moment in time. So that has no kind of forward or backwards looking element. That's basically saying, if you turn that off right now, that's how many
you get alerts. 52 alerts.
Now obviously it's more complex than that, because you might get 52 alerts, and then when those 52 alerts get to Alert Manager, hey, sorry, my dogs are fighting in my office, they will condense those down. So we have what's called group by rules, and it'll take those 52 alerts and say, well, we're going to turn that into one signal. Sorry. So you can, so it's not like there will be 52 pager duties, but there are 52 error conditions that might get rolled down into 1 or 2 pager duty notifications.
Yeah, I guess I can take a peek at that that data and see if I can maybe get that into the message. I think it would be really useful to have.
Yeah, and that's
When
not
you
to
do
say
go
that
to
it's
that-
not super awesome already. Sorry, Rachel.
When you do go to that front page, there are so many alerts that are silenced. There are so many. You can just keep scrolling down.
Keep in mind that a lot of them are like non-production often. I haven't looked today, but
Oh, I see. There's quite a few that are staging.
yeah.
Really silly question. Is Alert Manager something that we have made, or is it some software that it's open source thing that we feel with? It's part of Prometheus. Okay.
It's kind of like a side, separate but the same. They sort of work together, but they're two. I think they've got different maintainers, for example.
I see. Okay. Yeah, I can see how this is going to be super helpful for the people coming onto on-call, not having to look into things that are already there. That's a, yeah, nice addition there.
Yeah, the number of times I've like seen an alert and panicked and then been digging around, and then 30 minutes in, I'm like, wait a minute, this has got a silence on it. And then so yeah.
Yeah, it's happened to me so many times.
Cool. Anything else we want to cover today?
I'm just going to do a bit of bite shedding on that. Igor, I was just looking at the message today, and I don't know if it's worth doing it in Woodhouse, but like all of those silent, there's like what, 1, 2, 3, 4, 6 silences, but they're all actually related to the same issue. And I'm wondering if it would be possible to group. Did we already talk about that? No. Okay. Yeah. I was just wondering if it'd be possible to group by issue, because like, I think visually it's easier to say like this issue has these silences rather than these silences have these issues. If
yeah, that's a good point. I hadn't considered that. I think I'd like to gather a little bit more data on that to see if
I think this is probably an extreme
the
case
common
today.
case, or if it's just we had this one case where there's a lot of I don't
think we normally have that many silences for the same issue.
I mean,
but,
in my experience, it's usually 1-to-1.
Mm-hmm.
And I guess we kind of have that mapping via Helicopter as well, because Helicopter does do that grouping per issue. So we might be able to get some historical data on that as well to see if it's worth it.
Further bike shedding, should we just bring Helicopter into Woodhouse? Because it makes more sense for it to be in there.
I mean, my default answer to should we bring X into Woodhouse is probably yes.
And for once, it's not written in Node, so it's like it should be pretty easy to port across.
All right, Helicopter actually is in Go.
Yeah, it's a Go binary. I'm pretty sure. I think so. Yeah, pretty sure.
Yeah, I mean, we have quite a few of these tools. Like there's handover generation, there's newsletter generation. There's a whole bunch of them, and they're deployed in various different places. And I do think there is some value to bringing all of that into Woodhouse. I mean, that's kind of what Woodhouse was designed to be. It's like the central place for this type of thing. But also, is it really worth it doing that now? I mean, usually the answer is no.
There hasn't been a change to Helicopter in like over a year. Like it just does its job, so leave it be.
Yeah, that would be my take as well.
But that sort of there's also this other incident reports that I've been talking about us needing, and I spoke to Rachel and I spoke to you about it, Igor, and maybe that would make more sense just to build, because we're going to build that from scratch, and there's so much other incident reporting already in Woodhouse, or at least some of it. Maybe that would, I know Rachel, you asked that it was written in Ruby, but
I can see
maybe,
now if there's a whole other suite of
Yeah.
things doing this, that aligning the language with whatever the suite of tools
Yeah.
is doing makes sense.
I might look at that, because that was that other presentation that I put together the other day with all the incidents and the causes of them. The takeaway from that was that we really need to kind of look at triaging the labels on the
And having
incidents a bit better.
Yeah, and having a proper process around that, like because I fully agree. Like, I really want that incident data to be good. I think that the only way to get it good is to triage it and to have a process. It's just a case of who's responsible for it and when does it happen. And I'm hesitant to ask on-call engineers to do even more at their end of their shift, because it's already hard to get people off of the on-call process and back into whatever project they're doing, and then adding an extra, oh, you've got to triage everything. Like, it's
I was wondering whether it would make sense to, in the same way that we review the InfraDev report in the engineering allocation once a week, whether we should have it in the incident review session, and we can kind of, because the data that we have in the InfraDev report is really useful and kind of sets the tone of the engineering allocation call. It's like, this is where we're not meeting SLO and everything like that. And we could almost have the same thing on the incident review, where it's like, these are the labels that we're commonly seeing, this is whatever, whatever data we choose to put in there. And so having it in the incident review call and piggybacking on that.
But then are you implying that the data is already good by the time the incident review call happens?
No. So maybe what you can do is in the call, the first week round, there's like this is the data that's less than 2 weeks old, that hasn't been marked up properly yet, and like, this is how many things need to be fixed, but like within a 2-week period, so you're not putting immediate pressure on the engineer on call. And then further down you have, and this is like, because the thing is, incidents are rare enough that in order to get any statistical information, you can't be looking at the last like week or 2 weeks anyway. You have to be looking at trends over a longer period of time. Yeah. And so but you give people like 2 weeks to kind of work on cleaning the data up a little bit, because it doesn't matter within a day or even a week, I would say.
Well,
it's the long-term trends that we're trying to measure.
I know it sounds like I'm arguing a lot or disagreeing a lot about it, and I'm not, but I feel like if you give people 2 weeks to do it, it won't get done, because again, people move on to the next thing. I'm trying to think. So the development department also uses like labels as metrics, or like they also use issues and merge requests to produce the metrics that they use to run the department. And I'm wondering who has the responsibility on their side to make sure that those things are up to date. Like, is it the managers? Is it the engineers who do it? Is it quality?
I think it's the managers.
Managers
and the PMs. Yeah, I mean, that's. And they have a lot of bots. The difference is that they have a lot of bots that are pinging you as soon as you create a merge request, right? And it's like, and we don't want to do that, because there's a different time. Being on call is a much more synchronous process, and being on call is something that's time starved. So we don't want to ping people immediately and say, you're in the middle of an incident, please add these 17 labels to your incident right now, and they better be right. So it's better to do that after the fact with those, I think. I mean, with InfraDev, it's basically me doing it once a week in preparation for the call.
Yeah, and long term, we'd move that over into one of the scalability teams. I think.
Yeah.
In the longer term, us having that and then eventually automating it makes sense. But
you can't automate it though, because there's always a human. You can automate pieces of it, but there's always a human element to it.
Automating the fact that, like, generating the list of work that is needed to be done. Like, these are the list of issues. These are the ones that don't have what we need. These are the ones you have to look at.
And that's what we've got in that InfraDev report. With the sections.
But for the incident information, it's a bit different. Yeah, as you said, you can't do it at the time. Putting it on the EMs is slightly different. Like, there's less of a support structure around that. So it's a tough one.
But that's why we do have this call once a week where we review what's happened, and maybe that's the time to, it seems like it's a natural kind of, I don't know, Igor's kind of yes and knowing. He's probably got some opinions.
Yeah, I mean, if it turns into sort of a group paperwork exercise, then that could also make that call kind of more boring. So that's kind of the risk that I see there.
I think it's got to happen before, like it's got to happen as like maybe that's the deadline for it. And it like in this, like I don't do the labels on the InfraDev issues on the call. I do it like an hour before the call. And if we split that up between, I don't know, the person, it's anything that's between 1 and 2 weeks old is going to be is due, and it's up to the engineer on call who took the original call to put those labels on, or something like that. I don't know. There's lots of other stakeholders in this, so we can't really decide anything here, but we can talk about it.
It's all about having a proposal to put forward, because I think it's been a problem for a while. Everyone agrees we should do something. It's just no one can figure out what the something is. So.
Totally.
Cool. Is there anything else anyone would like to demo, or would people like some time back?
I missed the start of the call. Maybe I want to talk for a little bit about something I've been investigating, because it's on my mind and maybe people have ideas. Okay. So we had this long string of recurring incidents with File43, which hosts a repository of a known customer. And we now know that actually all GitLab servers host a repository from this customer, but more than one. But File43 had incidents, and they seem to be centered around that one repository. And we also believed that they had to do with one RPC and then one GitLab RPC. And then people made application changes on the client side so that RPC gets called less. And then it seemed that the incidents stopped, but they didn't, because the past few days we had a couple of basically the same incidents again with the same symptoms. So the system goes into 100%, almost near 95% CPU saturation, and profiles look the same. So well, maybe it's happening less often. Maybe we never knew what the trigger was. Maybe there are multiple triggers for it. But I started looking at this again. And I only found out about it because I wanted to tear down the script I made that automatically profiles the server when the load goes up. And I thought, let's see if it did anything in the past week. And then it actually did something.
Also, we've gotten paged for it.
Yeah, then I noticed
2 or 3 days.
Yep. Yeah, exactly. It was like on the 9th, it was yesterday. And it seems to be in the, well, what I would call the night. So in the 1 to 2 a.m. UTC range. But maybe that's too specific. And yeah, so I've been trying to look at that, trying to understand what's going on, and learning things about the Linux kernel. And it's a bit of a mystery, because what happens is, I talked to Sean about this yesterday too. Let's see if I still have some of the graphs up. Yeah, so I have an example, some example data here. This is from one of these incidents. So this was yesterday. I don't know if we've had another one. And this is the incident. Quite clearly, this is the total CPU usage across the all cores of the machine. And if that is at 90 something percent, that's really bad. And one of the other interesting symptoms is that network utilization usually drops, and it's kind of weak. So the system is not sending out a lot of data over the network. It's also not doing a lot of disk I/O. Oh, I'm out of Grafana. Let's see. And now it forgot where it was. Thank you, Grafana.
Yeah, that's really annoying. The Grafana thing.
Maybe this is it. Yes, I think I'm back. Luckily, the back button works. Yeah, and there's two ways we can get alerted on this, because one is that this app text dips, and the other is, of course, that these errors go up. And the errors are probably, yeah, they're spawn timeouts. So that makes sense, but when the spawn timeouts are happening, things are already bad for a while. So I think the app text is really a reliable indication that something's wrong. And the typical picture you see, this is another graph that we know means something's wrong if scheduling waiting is high. As is this, which is kind of the same thing, but with disk IO mixed in, but disk IO is not a problem in these incidents. And the yeah, if you look at what processes are active, it is Gitly and GitLab back. So they are competing, or they are both on the CPU almost all of the time. And so this is from yeah, 344. A moment, I have a profile for this. I just need to find it. I didn't prepare this. 344. So this is a profile from 344 on that server. So that's the start of the incident. And what's interesting is that, what I find interesting is that these, well, when I was talking to Sean, I said roll spin unlock IRQ restore is very busy, but I now understand that that is just a symptom. That is a technical detail of how the flame graphs work. When this function, there are times when the flame graphs can't see what's going on. And when they start seeing what's going on again, it looked like everything happened in this function, but there's stuff missing up here that we can't see with the flame graph. But what you see right below it is a hint of what's going on. So this wake up sync key thing. And so the weird thing here is that this is git upload back. And it's trying to write data, and it's spent almost all the time it's spending there. I mean, some of this time is spent on, this is just for interrupts, for the soft interrupt, also interrupt. One of these very thin things is going to be copying data. Mutex log, where are you? What else is here? Copy page, 0.02%. I don't know if you can see it on the screen. So this tiny slither is actually copying data, and all the rest of this is trying to wake up the process on the other end. And the process on the other end is Gitly, and that is this thing. Well, those are these read calls, and here Gitly is trying to wake up Git upload back. So they're going back and forth trying to wake each other up, and they're spending most of their time doing that, not sending any data out of the network. And the other really weird thing is that this upload back activity is all going through the back objects cache. So it's going through Gitly hooks, but that is only spending this much time on the CPU. So it's not like getting that data out is intrinsically a lot of work, because Gitly hooks can do it with this much work. But then it goes from Gitly hooks into Git upload back, and so here it is reading from Gitly hooks. That is also not a lot of work. But then the same bytes have to get written to the Gitly process, and then we get this big chunk, which is 2 separate writes. So there's something weird going on here. Am I getting across that it's weird that the bytes need to travel, and all of a sudden all the time is spent on this? Does that make sense? Well, it doesn't, but does it make sense that it doesn't make sense? So that's what I've been looking at, and I started writing a little program to simulate this, where I have a Go process that reads from a bunch of sub-processes, and I have a little C process that writes data in the same chunk size as Git does. And I try to run a lot of them at the same time, just to send data through a pipe, because this makes me wonder, like, is there a problem with sending data through a pipe? Because we're not spending a lot of time reading the data from disk. We're not spending a lot of time in Git compressing the data or traversing object graphs and finding the data. It's just, we're ridiculously busy sending it through pipes. So that's a mystery, and thanks. I have an issue for it. I haven't written a lot of comments on it, but I'll post more there.
So next week we can expect the second installation of this looks weird. What's going on here for,
Well,
for 43?
Next week I have a week off, but well, hopefully we can figure out what's going on here. But something's not right, and I feel that it's important to chip away at this problem.
Yeah. Well, one of the questions that comes to mind looking at that, maybe you already have an answer to this, is the profile doesn't tell us how often these things are being invoked, right? Like it just tells us sort of statistically a percentage of time. So looking at how many write calls do we have? How many of these processes do we have? And like, is it just many of these doing it for a short period of time? Or is it a few of them doing it for a long period of time, I guess is kind of what I'm getting at.
The process count is around 60, which is the limit per repository. There's also these things down here. What's that? Oh, that's 18 GitLab processes. That's because it can't fork fast enough. So there are a bunch. From looking at logs in other incidents, I think they tend to be long running because they can't get their job done. Because they're cloning a large repo, like this particular project has a lot of the fetches are 1 gigabyte. And if the system isn't moving very fast and doing a lot of them, then you're going to see individual 1 gigabyte clones that take a long time. In other cases, in this graph, you can see it, but I sometimes also see 60 processes at the same time and everything's fine. So I'm not sure if 60 is, at least it's not an unbounded number of processes. It could be that 60 is too much and that we need to have a lower limit. When it comes to
what also just jumped out at me is and maybe this is normal, but on what you just had open, the number of threads was really high. So, I mean, maybe that's normal. It's Gitly hooks.
It's okay. Gitly hooks, and that might be just a side effect of the Go runtime. So how many Gitly hooks processes are there? 67.
So it's Go max procs, which is the number of core logical cores.
Yeah, if Go is eagerly creating those threads, that would push the thread count up. But if you look at CPU utilization, these threads are not. Most of them are idle.
Yeah.
So, well spotted, but that's probably not it. This is 334, 15.
And one other idea that I had, just to get it out of my head, for the CPU profile, if we captured the PID, and I think we do capture that by default, we could do a flame graph that includes the PID. And see if it's correlated to a single process.
I've been wondering that because there's some sort of weird many-to-one thing going on where there's many GitLab back processes talking to one GitLab process and they're waking each other up back and forth. But like you say, maybe it's just one of them that's waking up GitLab all the time, or maybe they're all waking them up, or we don't really know what's going on there. Also, this is a different dashboard, but these pictures are exactly the same as the the same file 43 incidents that we had before, where we see that all the CPU time is spent in the kernel, and that adds up with that picture because if you look at this flame graph, all this is kernel. So, right, once it's in these syscalls, so it makes sense that here this big chunk of blue is all the time we're spending in the Linux kernel. The orange must mean something. That's soft IRQ because that also goes up. But I don't know yet exactly what it means. One thing is that you were asking about writes. So if you look at system context switches, writes are context switches, but there are context switches that are not writes. But if you look at the start of the incident, it is not marked by a big increase in context switches. There is definitely something going on, but context switches only go up here, and then the thing stops. So it's not like we have a zillion writes all of a sudden. That's what I was trying to show here. So ongoing mystery. Thanks.
One last thought on something to potentially look at. If we open up that profile in Flame, so what you just showed was that the behavior kind of changed over the course of the incident, right? The CPU utilization remained high, but we kind of start out with low context switches, and only halfway through do we actually start going up.
I actually have 10 profiles, and you can also see the profiles change. So
okay,
what changes in later
yeah.
profiles? Okay, let me share again. I can show a later profile. What changes in the later ones towards the end? Let's try this one. Actually, this one still looks the same, but at some point the socket writes in GitLab pick up. We start doing more socket writes. And one pattern I see in these things is that, yeah, here already you see these towers are smaller, and the socket writes are getting bigger. 54. Yeah, here it's all it's dominated by socket writes. So this is a very different profile from the first one.
Yeah.
Then the first one, it's all I'm trying to wake up somebody on the other end of a pipe. And there are socket writes here, but not that many. And then here the socket writes are dominating TCP send message.
This is really interesting.
Yeah, and I wonder if what we're seeing here is that somehow the socket writes get unblocked, and it's starting to send a lot of data. But where are we buffering that somewhere? Like, do we even have room to buffer all of that? Well, if we did, then GitLab should get bigger, but GitLab is this one at 4 GB. It's not really moving during the incident. It's not like GitLab's ballooning up all this data from the upload back processes and all of a sudden starts sending them through the TCP sockets, I think.
Yeah.
But yeah, it seems something gets blocked and everything is just doing these stupid wake ups, and then it gets unblocked, and then we start sending more data, and then we're good again. And you also see it in the network graph. You see this peak here. And this is probably trailing because it looks back. It's probably a window, because it's a counter, the network transmit rate. So the number would be a rate over a 1 minute or 2 minute or 5 minute window. So the fact that this peaks after we're done, actually it sort of lines up because the other profile is 54. So yeah. It's a pattern. The same thing keeps happening there, and there must be something we can do about it, and there must be an explanation. Is what I'm hoping. Thanks. That is for letting me ramble, because this was completely improvised.
No, thanks for sharing it. Great. Well, if that's all on our cards for today, I'm going to go ahead and say thanks very much for the conversation. I'll upload the video. I hope you have a good rest of your Thursday.
Thanks, everyone.
Bye.